try. It was a good one. However, what you've done, most of you have done, okay, you've done Ka. You've taken this one to be Kh. You see, the question wants us to calculate the degree of hydrolysis, and we have the concentration of the salt, which is potassium cyanide, and we have the dissociation constant, Ka. So we have the potassium cyanide, okay, potassium cyanide, which fully or which completely dissociates to give us 0.1 molar solution. Oh, it's okay. To give us potassium ions and cyanide ions. I don't know what I was thinking about. To give us potassium ions, okay, plus the cyanide ions, and the minus is on carbon. Sorry for that. Then now it's one more. So, and since it is food ionizing, then it means you produce 1 mole of cyanide ions and 1 mole of potassium ions. Now the cyanide formed, remember, it's a weak acid. So this is a salt of a weak acid and a strong base. So the cyanide formed, it will undergo hydrolysis to react with water molecules, okay, to produce, this is half equation, to produce hydrogen cyanide, okay, and the hydroxyl OH ions minus. Now, the question wants you to calculate the degree. They have given you the initial concentration, the initial concentration of cyanide ions, okay, which is the initial concentration of cyanide ions, which is 0.01, okay, molar, and the Ka, the dissociation constant of hydrogen cyanide, okay, as 7.2 times 10 power negative 10, okay, power negative 10 moles per decimeter cubed. Now, from the relationship between Ka, Kw, and Kh, you remember Kh, okay, is equal to, you remember, Kw divided by Ka, and we derived this together. Do you remember? If you don't, you can still derive it again and again and again. We cannot get tired of doing work. But from this relationship, we know that Kw is simply, it's a constant, which is 1.0 times 10 power negative 14, okay, negative 14, and we are given Ka. So can't we get the hydrolysis constant? Yes, we can. So we can. And how? By simply substituting this into this formula and this into this formula, and we get the hydrolysis constant. So therefore our Kh is simply 1.0 times 10 power negative 14 divided by 7.2, you should get the answer for me, times 10 minus 10. And so the answer that we shall get is going to be the Kh. And what's the answer here?
0.139.
0.139. Oh, sorry, that's the 9. Let me clean. Let me try to clear. So 139. Okay, so this is 139, and the answer is in moles per decimeter cubed. By the way, let me show you how it is becoming moles per decimeter cubed. The kh is gotten from, okay, let me do it from here. Remember, it is concentration of OH times concentration of hydrogen ions. So the units for kh, for kW, it is mole squared, okay, decimeter, dm minus 6, so divide by moles per decimeter cubed. So that's how one is taking away this, and this one is reducing this to 3, and it becomes moles per decimeter cubed. Now you have the kh. Can't you get the h as the concentration of kh, sorry, as the root of kh divided by c, which is the initial concentration, which is simply 0.139 divided by 0.1, and so the answer is going to be the answer. What's the answer here? It's 1.1.
1.19. 1.179.
1.
1.179.
Are you sure? No, times
Yes.
10 here, times 10 here. No, it is 1.39. 1.39. Yeah, it's okay. There is root. Yes, so it becomes, our h becomes 1.179. That's it, eh? Yes,
Yes.
that's good. So now I've done this. Now you do the next. So calculate the pH of the solution of sodium ethanoate made by dissolving 8 grams per decimeter cube. Now don't make the yesterday's mistake. This one is they have given you the concentration in grams per liter. So you just need to convert it in moles per liter, and so you have the kh, we want the pH. So can't you do that chap chap? Yes, do it. Chap chap. Yeah, don't forget to go to our classroom. I posted there enough questions. Go there, you find there questions, you do them. You do as many as you can so that this topic becomes part of you.